This I just wanted to end with. Scott Kelly took this out of one of the windows on the station just before the launch occurred. And for any of you that are fans of 2001, this should be very reminiscent of that. So this is the limb of the Earth. That's Mars, Jupiter, and the Earth's moon. And I'll just leave you with this poster of the 6 folks that are on board the station right now. Okay, and then I wanted to move on to the other big story of the month, I think, which is the New Horizons flyby of Pluto on July 14th. And so just to refresh your memory, this is sort of the layout of the solar system. The Earth was in here. New Horizons was the fastest spacecraft ever launched away from the Earth. Most things that, if you're sending a spacecraft to Mars, it typically takes about 2 days before the spacecraft crosses the orbit of the moon. New Horizons did that in 9 hours. And it still took 9 years, a little over 9 years. It was launched in January of 2006, so 9.5 years to actually reach Pluto. And it will continue on into the Kuiper Belt, hopefully encountering another Kuiper Belt object around 2019. But getting back to Pluto itself, this is one of the best ground-based views of Pluto. I'm sorry, this is Hubble. So this is Pluto and its moon Charon, its major moon, which is half the size of Pluto, and then the discovery of 2 smaller moons, each measuring a couple of tens of miles across. And so we showed these last month. These are the images approaching Pluto. And so still pretty fuzzy up through the middle of June. This was Pluto and Charon together in one frame, and that was in late June. The approach speed was about 1 million miles a day. So every single picture, every single image that they sent back was the best image that had ever been received, because they were getting so much closer every time the camera was turned on. And this is a view from just a couple days out before the close approach. And that was what Pluto looked like and what Charon looked like. And so we were certainly starting to see evidence of features. The interesting thing on Charon is it's got a dark polar cap. The North Pole is about right here. And so here's actually, that's not starting. Could somebody hit the space bar on my computer? Well, I'm not sure what just happened. I'm sorry, not the space bar, but if you, oh gosh, click on it. There we go. Okay, so, and if you'd move the hand out of the way. So this is the, okay, don't put it in the corner, because that turns on the screensaver. Sorry about that. Let me back up, and let's start this again. Okay. All right. So this is a very sped up view of 12 hours before the closest approach to 12 hours after. And you can see how the spacecraft is gyrating around. This is a view of what the instruments are seeing. So there's Pluto and Charon, sweeping back and forth, looking at all of the different moons. Pluto has 5 moons total. And then as they zoomed past at something like 20 kilometers per second, and then looking from the dark side back at the Earth to do radio occultation measurements. So the telescopes, radio telescopes on the Earth were sending focused beams of radio waves at Pluto and Charon, or at the whole system, and then New Horizons turned its antenna to listen, and that's a way to actually probe the vicinity of both objects and determine characteristics of the atmosphere on Pluto. So that was the flyby. This was an image released the day before the flyby. So this was from about 1 million miles out. And here's Pluto, and there's Charon. The one thing that they saw, this was going to be the area that they got the closest approach on. So they were calling this the Heart of Pluto, this bright sort of heart-shaped feature. And the North Pole is up in this direction. And so here's the best image so far of Charon. There's it's that dark area near the North Pole. The things that really stand out, some of the areas have craters in them. Some areas are exceedingly smooth. There's a sort of a chasm that runs right, almost from limb to limb on this side of Charon, and here's another one right on the limb. This one is estimated to be something like 6 kilometers deep, so several times deeper than the Grand Canyon. And what's really got people's attention is these smooth areas, because you'd expect over the lifetime of this object that it would accumulate a lot of impact craters. And so older surfaces have very heavily cratered, are very heavily cratered surfaces. If you have a very smooth surface, that indicates that it's relatively young geologically. So either there's something that's erupted out of the interior to cover the older surface, or there's some process that's eroding the surface that wipes the craters out. And at this point, we don't know what the answer is, but the people on the science team have estimated, based on the crater counts that they see here versus here, that surface is probably at most 100 million years old, certainly not 4.5 billion years old. And so that really calls into question our understanding of these objects. The temperature in this part of the solar system is only about 30 degrees Kelvin above absolute zero, so it's almost minus 400 degrees Fahrenheit. This is an object made out of rock and ice, and you would expect it to not have much internal heat left that would allow it to be geologically active. And so that's certainly going to be a major avenue of investigation. So here's 2 of the smaller moons. Nix and Hydra. Each of these, I think in the longest dimension, is just a couple of tens of miles. So very tiny objects. And here's a composite of the best image so far of the entire disk of Pluto. And this actually is a natural color image. And so there's a little bit of reddish stuff up here near the pole. This is that heart feature. This is now called Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. And again, the things to really pay attention to is you see craters, although not all that many of them. In the surrounding area, you see no craters on the interior of Tombaugh Regio. And so we do have some images back of much closer. This was obtained from about the distance of the Earth to the Earth's moon. And so still not all that great, but the best images I'm going to show you were from about 1/10 of that distance. So say this is about 250,000 miles. I think the nearer ones are from about 25,000 miles. And so here's a couple just closer views. These are actually the images that went into making that previous full disk image. And here's our global map of Pluto at this point. So the North Pole is at the top. The south polar region we're not going to see because it was in darkness. And this is the hemisphere of Pluto that those previous images were from. Pluto rotates on its axis in about 6.5 days. So 3.5 or 3.25 days out from the closest approach is the best resolution that we will see for that part of the object. This is the part that we'll get much better views of. And this is a false color view where they've stretched or enhanced the color just to show the differences in color. We've got some very, very dark brown areas, this sort of reddish stuff up here. This stuff is almost white, but not quite. And so here's just zooming in on Tombaugh Regio now, and I'll do some still images of several of these. So that's now called Sputnik Planum, this area right in the center of Tombaugh Regio. And we'll look at both this area and this area in some detail. And so we'll start down here, zooming in. First thing is there's mountains. These are called Norgay Montes, after the Sherpa that went with Edmund Hillary on Mount Everest, the first people to climb Everest. These, based on the shadows, they're about 11,000 foot high mountains. Here's getting into Sputnik Planum. You see that this is very, very smooth. This area has craters on it. Here's a crater that seems to be filling in with this bright stuff. More mountains here. And here's the names of what we see. So these mountains they've named after Hillary. Here's this infilled crater, and we'll zoom in here on the Hillary Montes. So not something that was necessarily expected. Certainly not the difference between the cratered stuff and this very, very smooth stuff. And so now we'll look at this area. And this just, I think, is blowing people's socks off, because here's this extremely smooth coating here. There's polygons on it, which are very reminiscent of things we see in the Arctic on the Earth and on Mars, except these are much larger. And if you look closely up here, I'm going to zoom in, it actually looks like there's material flowing around these hills. And what that material is, they expect, is solid nitrogen ice. And the thought of that actually flowing is fairly remarkable. The taller mountains, they think, are made out of water ice. At these temperatures, water ice is like rock. So it would be sturdy enough to support very large mountains. Other ices that they expect, like nitrogen, methane, carbon monoxide ices, they're all a little bit squishy at these temperatures. And so potentially these are solid nitrogen glaciers. And this is just pointing this out. So again, here, this area is very rugged and has some craters on it. This is very, very smooth. We see no evidence of craters internal to this. And then there's this evidence of ice flowing around obstacles. So I think it's same as what we talked about on Charon. We really have to rethink, how could this happen? It's not like, say, Europa or Enceladus, where there are tidal forces that are stretching the moon frequently, and that causes internal heating and can drive geologic processes. The Pluto-Charon system, they're locked tidally, so there are no tides being raised on either of those bodies. And it's a big mystery. So this is just an animation flying in from the flow side of Sputnik Planum, just to give you the lay of the land here. Maybe that's a crater. And then this is flying over these the mountains in the south. That infilled crater that we talked about a minute ago. Okay, just a couple of other things with their spectrometers. They have detected methane, nitrogen, and carbon monoxide ice in the center of Sputnik Planum, so that is consistent with the models of what you might expect here. They're still trying to figure out how did it get there? Why is this sort of an isolated occurrence of materials like this? It could be that as Pluto moves in its very elliptical orbit, that it's moving away from the sun or getting farther from the sun for the next 200 years or so, and that the atmosphere could be freezing out, and they think the atmosphere is primarily nitrogen, and so for whatever reason, maybe that the frosts are concentrating in this area and covering the pre-existing surface up. But we'll certainly have much more information as the data get played back. And this is, I think, one of the really memorable shots. This has been compared to the Earthrise view from Apollo 8. So this was after New Horizons passed Pluto. It's looking back toward the sun, and what you're seeing is sunlight coming in through a hazy Pluto atmosphere. And it really is much hazier than they expected, and certainly very, very distinctly an atmosphere. And it actually rises about 100 miles, 160 kilometers or so above the surface. And when they have looked at this in detail, so this is sort of a blow up looking along here. So there's the surface, and there's at least 2 layers of haze in the atmosphere. There's one about 30 miles or so above the surface, and another considerably higher, about 50 miles or so above the surface. And this is an animation of how these ices might form and how they get altered. So the sunlight still has a lot of ultraviolet radiation in it. You have some methane in the Pluto atmosphere, and when it gets hit by UV light, it breaks it up into ethylene and acetylene, and then those molecules start combining, and they get altered by the UV, and they form sort of complex goop that falls out of the atmosphere as sort of snow or big smog particles, whatever you'd like to call it. And those are called tholins. And they think that's certainly where the reddish stuff and the brownish stuff on the surface is coming from. That it's raining out of the atmosphere, or falling out of the atmosphere. And then this was one more surprise. So from the Earth, they've made measurements over the years of the density of Pluto's atmosphere. And they do this by occasionally the geometry is just right that you can see a star, and Pluto passes right in front of the star. And so they measure the spectra and the details of how the starlight is eclipsed by Pluto, and you can actually see down to the surface through the atmosphere. And so it seemed like starting in this first measurement in 1989 or so, that they had about 5 microbars, that's 5/1,000,000th of an Earth atmosphere. And then over the years, it seemed to be increasing in pressure, and which was sort of a mystery because it should be decreasing because it's getting farther away from the sun. So here's the measurement that they made with this radio occultation experiment on New Horizons. And so that would indicate that we're almost back to where we were in 1990. So that's another line that they're going to be investigating of, is there something systematically affecting these measurements, and this is more or less the same as this, or has there actually been a change? And the one possibility is Pluto is just now getting far enough from the sun that the atmosphere is starting to collapse onto the surface, and they got very lucky at being there while there was still an atmosphere. They did the same sort of experiment looking near Charon. And so this was with an ultraviolet experiment looking at a star that passed right behind Charon. And this is, the starlight, and then when it hits the edge here, it just drops to 0. And then it comes back again. And so that indicates that Charon does not have an atmosphere, at least a detectable one by this technique. So that's sort of where we are on New Horizons. The way this worked is they had to record all of the data from the encounter on board the spacecraft, because the instruments on board are fixed to the body of the spacecraft. So in order to point the instruments, you have to point the spacecraft. And that means the antenna is pointed away from the Earth. And so that was from about 19 hours before the encounter to about 19 hours after the encounter. So the entire 38-hour period is on board the spacecraft in memory, and they're playing it back at something like 1,000 bits per second. If you remember back in the early days of having dial-up modems, at least the oldest one I remember was about 300 bits per second. And then I thought I was in hog heaven when I got up to 2,400 bits per second, and then you get up to 56 kilobits. And of course, DSL is in the megabits per second. So it's going to take a long time, and it's actually about 16 months to play back all of the data. At this point, they've returned about 5%, and it's all being played back in heavily compressed form. So they're going to get all of it back in compressed form over about the next 4 months, and then they start playing it back uncompressed to get the full resolution data. That mostly affects the images, because they're so data hogs in comparison to the other instruments. So these are pretty good images, but the same image when it comes back in uncompressed form will be at least a factor of 2 higher resolution than what we're seeing right now. And there are much, much higher resolution images still on board the spacecraft. So I want to end up, and I'm going to rush through this. I usually do updates on Opportunity and Curiosity. I'm just going to say they're both still working. Today is day 4093 for Opportunity. This is where it was sitting a week ago. It's about to enter this area called Marathon Valley, and it's showing its age. It's been having computer memory problems where the flash memory that holds all of the instructions has been corrupted, probably by cosmic radiation, and it keeps rebooting itself. They reformatted the memory a couple months ago thinking that would help, and it sort of did for a little while, and now it's back to doing reboots every few days. So that's certainly hindering progress, but it is still able to return data. And so here's the statistics. Day 4097, it's driven 42.45 kilometers and returned almost 205,000 images. So Curiosity is coming up on its 3rd anniversary on Mars. August 12th is the anniversary of the landing, and so it's Martian Day 1059 today. And just to refresh your memory, this is Mount Sharp, and they're sort of working their way probably up to about this point. Right now they're sort of about that level in the foothills. And this is the most recent thing that they've started investigating. This is a contact between 2 different types of rock. They think that below this line, this is all mudstone. So it was very, very, very fine sediment laid down underwater. This is sandstone. And so they're investigating, it in very close-up detail, these 2 types of rock. And I'm going to zoom in, and I don't know where this next one is in this scene, but a really nice piece of this mudstone. And you really get the feeling that that was like putty when it got laid down. The edges are curled, and it's very, very, very fine-grained. So this, I should put this to scale. This is about 8 centimeters across. So it's this is with the microscope camera. This is about 30 centimeters across. So it's still a very small view here. So there we go. Day 1059. It's only driven about 10.5 kilometers so far, but we're coming up on, well, we've passed 250,000 images returned so far, and it's going strong.